are, so we'll just say find the axis of symmetry in the vertex. You don't have to graph it. It's up to you. Like, if you want to just watch, that's fine, or you could do whatever. So you don't have to graph them. You'll just, and it will specifically say just find the axis of symmetry in the vertex. So you know you're doing x equals negative b over 2a. So with something like this, your b value is 0, right? So a is 2, b is 0, c is negative 7. So negative 0 over 2 times 2 is 0 over 4, which is 0, right?
Yeah.
So we know our axis of symmetry, and you'll write it as an equation, so x is equal to 0. So to get full points, I'm going to push people to write like this, because that is the equation for the axis of symmetry. Because it's x equals, right? We're writing x equals 0, not just 0. A lot of people put 0. It's x equals 0. Does that make sense? And then vertex is 0, comma, whatever you get, and you plug it back in. Right, so it'll be negative 7. So these two are your answers. There'll be 2 problems like this. So now this one, same thing. Axis of symmetry, x equals the opposite of b over 2a. So, yep, positive 8, because negative 8, c is 4. So the opposite of b would be positive 8 over 2 times negative 2, right?
Yep.
So a over negative 4, and that's negative 2, right? So you have x is equal to negative 2 is your axis of symmetry, negative 2, comma. Let's plug it in. So we'll be really careful, because we'll have to type it in like, so we have negative 2, and then we're doing negative 2 squared minus 8 times negative 2 plus 4. So we'll type it in just like that. Negative 2.
Plus 4?
Yes. Okay, 12. 12, just make sure real quick. And then minus 8. 12, good. Yep. So that's how you'll do those. And then the second, so you'll do 2 problems like that. Then it will say graph the function. And then I have it laid out like this on the test, because I want, when graphing, you know, these are the steps we take. If it's in standard form, that is. So once again, let's do our axis of symmetry. So x equals the opposite of negative 6, so positive 6 over 2 times 1, right?
So, negative 6.
Because a is 1, and b is negative 6, and c is 2. So x equals negative b over 2a. So opposite of b would be positive 6 over 2 times 1, which is 6 over 2, which is 3. So our axis of symmetry is x is equal to 3, and we'll draw it in. And then we know that obviously the vertex is on that point, so 3 comma whatever we get, and we plug it in. So 3 squared minus 6 times 3 plus 2. Hopefully. So let's see. 3. Plus 2, yes. Negative 7. So our vertex is at over 3 down 7. So right there's our vertex. And then we find the y-intercept, and that's always algebraically when x is equal to 0. So you plug in 0, you'll have 0 squared minus 6 times 0 plus 2, which is just 2, right? So our y-intercept is 0, comma 2. So we're going over 0 up 2. It's crossing the y-axis at 2. And then we're going to find 2 other points. I don't say to do that, but that's what you need to do. So I'm going to go with points close to the axis of symmetry. So yeah, like 4 would be great, but if you know 4, well, you know 2, since they'll be even. So let's go with 2. That's a good one to do. So I'm going to plug it in. So 2 squared minus 6 times 2 plus 2. 2 squared minus 6 times 2 plus 2 is negative 6, right? So we have another point 2, negative 6 on the graph. So over 2 down 6. So then we know that we have a point equally across the axis of symmetry on the other side. So here, right? And then same here, up 1, 2, over 1, 2, 3 from the axis of symmetry over 1, 2, 3. So we've now found like plenty of points to be able to draw this.
Okay.
So now we'll draw it in. So just question, is that a max or a minimum value? It's a min, right? Isn't that the lowest? Okay. Now domain and range. So domain, where's your function going from left to right? Yeah, negative infinity to positive infinity, and all quadratics will always be domain negative infinity to positive infinity, because they always grow this way forever, even if they're flipped downwards, right? And then your range is your y values. You want to do your smallest y value to your highest.
So negative 7.
Yep, so -7 is your lowest y value, and it's growing to positive infinity. Now here's the catch. It included -7. You've got to put a bracket, yeah. My infinity is kind of weird on that. Okay. So your second problem on the test will be graphing, and you have to follow these steps and write them correctly. So your axis of symmetry will be written as the x is equal to 3. Your vertex will be written like this. Your y-intercept like this, and so on. Okay. Okay, so now I'm just going to say solve. The next thing you'll run into on the test is just solving quadratics, and I'm just going to say solve by your method of choice. So you'll get it right more likely if you use the most appropriate method. So with this one, we're missing the x, right? So we'll just isolate x squared by adding 64. So x squared is equal to 64. Now check and make sure x squared is completely isolated. If there was something multiplied to it, it's not isolated, but in this case it is. Yeah, if it was negative, good point. Yeah, we'd still have to divide the negative. Yeah. So now we'll take the square root, and our root cancels out our power. We get x is equal to plus and minus 8. And if you forget the plus and minus, I'm marking it completely wrong, I think. I haven't decided, but probably. Don't forget the plus and minus. So just always check, like when you're solving a quadratic, you should always have 2 answers. Okay, so we have 2 here. Moving on to this one. So once again, looking at it, we have 2x squared minus 18 is equal to 0. We're missing the middle value of the x again, right? So, yep, same thing. Isolate x squared, so we'll add 18. So we have 2x squared is equal to 18. Now this is where students get a little bit ahead of themselves when they square root it right here, but we would need to divide by 2 first, right? So we have x squared is equal to 9. Take the square root. Do not forget, when you take a square root, you have to account for the is equal to plus and minus 3. Yeah, I did. Okay. Are we good with those? Do not forget the plus and minus. Okay. So then with this one, well, first of all, one thing I need to say is, luckily in all these, I should have said this in the beginning, we always have to make sure it's set equal to 0. So that one was good, that one was good, and then this one's good as well. It's set equal to 0. So we can just start to solve. I'm going to do factoring on this one. So a times c, so 1 times -15, what multiplies to be -15 and adds up to be -2. 5 times 3, the negative would be at the 5, right? Then because our a value is 1, we can factor it to be x minus 5 times x plus 3. If it was equal to 0 up here, it's equal to 0 down here. And then the 0 property rule says we can set each of those equal to 0 and solve. So we get x is equal to, we'd add 5. We would subtract 3 from both sides, so x is equal to -3. So yeah, if you can solve by factoring, I obviously would suggest that strongly, because otherwise you'd have to go through the whole quadratic formula, and you would have got the same answer if you would have done it correctly, but way easier to factor. Just make sure you don't get them backwards, because a lot of times when people factor, they'll forget that it was -2 and write 2, and then your factors are wrong. You know what I mean? Okay, so just be really careful. I don't want you to miss those. Okay, so you're good with these. Okay, so let's just do a couple more. So solve by your method of choice. We have a squared minus 12a. The first rule is always get your quadratic equal to 0. So to bring 12a over, I've got to subtract 12a. So I have a squared minus 12a is equal to 0. So from here, if you try to do a times c, your c value is 0, right? Well, you shouldn't do it that way. What's in common in the beginning? Okay, let's factor out an a. Now, when people say, oh, there's an a in common, so I divide by a, they forget you have to write it out here. Because when you factor it out, it doesn't disappear, right? So you write the a. Now you go back and divide each term by a. So left in this first term is a squared divided by a, which is a, right? Negative 12a divided by a is negative 12. And now we factored it. And now we have linear factors, degree 1, so we can set each of them equal to 0. So we have a is equal to 0. We also have a minus 12 is equal to 0. Solve for a in each place. So a is equal to 0, solve for. We'd add 12. So a is equal to 12. There's our second answer. That one's one of the most missed problems, and it's one of the easiest ones on the test. Don't miss it. Okay, awesome. So then with this one, we have x squared minus 7x is equal to 3. It's not equal to 0. Let's make it equal to 0. Now careful, this is positive 3, right? So to bring it over, won't we subtract 3?
Yeah.
But what if it would have been negative 3? Will we subtract 3 again? We would add 3, okay. So we would subtract 3 from both sides, so we have x squared minus 7x minus 3 is equal to 0. Now if you try to factor with this one, you'd be looking for what multiplies to be negative 3 and adds up to be negative 7. Well, there's no factors that work, right? So it's not factorable. So this is where we'd use the quadratic formula. So a is 1, b is negative 7, c is negative 3. So we do x equals the opposite of b. So do I need to write out the quadratic formula, or do you guys all know it really quite well? You know it really well? Okay. So the opposite of b, which would be positive 7 plus or minus the square root of b squared. You have to use parentheses. Minus 4 times a times c and all over 2 times 1. So the discriminant, you said you calculated that, you simplified again, and that is the discriminant. Good point. What is it? 61, okay? And then that's all over 2. So then this is always where we go off to the side, say, does the square root of 61 break down? Does 61 break down? It doesn't break down, right? So we would leave it like this. There's our 2 answers. So we really have x is equal to 7 plus and minus the square roots of 61 over 2.
Are you okay with writing plus and minus?
Yes, this one's fine. Yeah, as long as you understand there's 2 answers there. And then what if this would have been like a 6? Could we divide out 6 and 2?
No, because it's not 3.
No, right? Yeah, because all 3 has to be able to divide. So don't do that. Okay, awesome. Are we all okay with that? Did I go too fast? Let's do another one. 3x squared is equal to 2x minus 7. So let's get it equal to 0 first. So I'm going to, because this is positive, I'm going to subtract 2x. But if it was negative, we would add 2x, right? You've got to get your signs right. So we have 3x squared minus 2x is equal to negative 7. Now to bring 7 over, we would add 7. So we have 3x squared minus 2x plus 7 is equal to 0. So if you wanted to try factoring, you could. You'd say what multiplies to be 21 and adds up to be negative 2. I can't think of anything, right? No. 7 and 3, but then that doesn't work. Okay. So let's go ahead and do the quadratic formula. A is equal to 3, b is equal to negative 2, c is equal to 7. So we have x is equal to the opposite of b, which would be positive 2, plus or minus the square root of b squared, negative 2 squared, minus 4 times a times c, and it's all over 2 times 30. So then, yeah, this is where you'll type just this piece into your calculator. So we have x is equal to 2 plus and minus the square root of
Negative 80.
negative 80, and that's all over 6, right? So then we always go off to the side and say, okay, let's break down the square root of negative 80. So that's negative 1 times 80. So we're definitely going to be pulling out a negative 1, right? And then we'll break down 80, 8 times 10. 8 breaks down into 4 and 2. This breaks down into 2 and 5. And this breaks down into 2 and 2. So pulling out groups of 2, right? So there's 2 2's. So we'll pull out a 2 times 2, right? So 4, and then left hand side was a 5. So don't forget you also pulled out negative 1. So we have 4i, because 2 times 2 is 4, times I, and then left was a 5. So 4i square roots of 5. Is everybody comfortable with how to do that one? One of the more tricky ones. So let's replace that. So we have 2 plus and minus. We got 4i square roots of 5 for this. All over 6. Now you look, do all 3 things, because a lot of people tend to divide it out right here, and you'd be wrong. Don't say 2 and 6 divide out. It has to be all 3 things. So now we can say, okay, they all divide by 1. They all divide by 2, right?
Yeah.
But make sure, okay, so go through and divide each thing by 2. So this is a 1. A lot of people say, oh, that's gone. It goes away. But that's not true. It's a 1, right, everybody?
Yeah.
This is a 2. This is a 3. So your answer will be x is equal to, don't say that's gone, it's a 1, plus and minus 2i square roots of 5 all over 3. There's our 2 imaginary solutions. Okay, questions? Okay. So that's all for solving quadratics.
I would have thrown out the 2.
You would
That's what
have
I would have done.
thrown out the 2?
Thrown out the 2.
Oh, yeah. Yep. Okay, oh yeah, this one. Solve. How do we solve it? Yeah, aren't they linear? Degree 1? Linear factors, so they're already factored for us. So we'll just set, we know the zero product property rule says if the whole thing's multiplied and set equal to 0, we can individually set them equal to 0. And oops, minus 1, that's a 1. Minus 1 is equal to 0. Now solve for x in each case, minus 3. So we get x is equal to negative 3. There's one of our solutions. You would add 1, right? So 7x is equal to 1, divide by 7. So x is equal to 1, 7. There's our 2 solutions. And once again, we wouldn't multiply it together because guess what? Then you'd refactor it and end up right back where you started. So they're already linear, set them equal to 0. Don't miss that one. Okay. The next thing on the test will be the, oh yeah, and I'm so glad you guys are here because it just hit me like a brick last night that a lot of people were doing these wrong and it was my fault because I was just not thinking right. So I taught half people how to do it one way. I'm like, oh, you can do this 2 different ways, but you really can only do it one way. So it says, a melon is tossed in the air with an initial velocity of 23 feet per second. Its height, h and t in feet, after t seconds is given by this quadratic function. After how many seconds will the melon hit the ground? The only way to do this, because I think I told many of you, oh, find the axis of symmetry. Like, if you find the axis of symmetry, then you know it's evenly split. But we have no idea if the parabola is from here to here or from here to here. This just tells us how far over to go. So I was totally just not thinking right in that. So what we would need to do is we need to find the actual x-intercept, right? Because this is the actual length of how long it was in the air. So we need to actually solve the quadratic and then find that distance, you know? So this was like, for example, let's do something really easy. Let's say we solved it and we got this was -2 and this was 8. How much total distance is that? 10, right? Even though this is -2, isn't that 2 this way and 8 this way, so 10? Do you see how to find the total distance? So that'd be 10 seconds. But these answers are going to come out hideous. So maybe you'll use the quadratic formula. So x equals -60, right? Opposite of b. Plus or minus the square root of b squared. So 60 squared minus 4 times -16 times 6, a times c, all over 2 times -16. So we should all type that in. We're going to get some hideous decimals. What? So let's actually find the whole decimal on that. So, yeah, let's figure out really quick what was under the discriminant. Sorry. What was the discriminant, I mean?
I got 39.
39, it is big. 3984, that's right. And it's all over -30, right? Okay. No, -32. Sorry. Okay, so now find those 2 decimal answers, because we can. Let's all practice that. So you'll do -60 plus the square root of 3984. Hit enter. Divided by -32, and you get negative. Okay, so you get. I'm gonna give myself some room. You get -0.09746. I'm gonna do quite a few decimals, if not the whole thing. So 667,298. Okay. So I get that decimal. That's one of our answers. So we're at. If we were so we're crossing right here at negative point that, right? -0.09. Is everybody okay with that? Now we'll find the other one. You'll do -60 minus the square root of 3984. You have to hit enter first and then divide by -32. And you get 3.84746673. Okay, so this is in the positive direction of 3.8, right? So let's find that distance. This is a positive distance, right? If we're talking distance. So you would add up that plus that, right? So that plus that, but not with the negative, right? So we're talking distance. Does everybody get what I'm saying?
Yeah.
Okay, so we'll go. So I already have that decimal, this huge decimal typed in, and I'm going to go plus, so I don't have to retype in both, 0.097466728. I hit enter and it's 3.9 seconds. That's how long it is in the air. That's the only way to do it, is solve it and then calculate the distance. Because when we were finding the axis of symmetry, we were way off, because that's just how far left or right we go. We have no idea where it's ending, you know what I mean? So you'd have to solve it, then calculate that distance. Obviously kind of an advanced problem, so you can do it though. Okay, moving on. So the next thing on the test will say what type of function best models the data, write an equation. So we always look at, so first of all, notice our x values are going in order, right? So that's just when we take differences, and then we'll see if it's linear, quadratic, or exponential. So negative 11 minus negative 12 is, so negative 11 minus negative 12 is, 1. And then negative 8 minus negative 11, 3. And then negative 3 minus negative 8 is 5. And then 4 minus negative 3 is 7. Were they the same? No, right? So it's not linear. We take differences again, and you always start with the y value that comes before the y value above it. 3 minus 1 is 2, 5 minus 3 is 2, and 2. So it's quadratic, right? Because we took differences twice. So you'd say quadratic, and then you would do the stat, and I don't want to have to go through this because we really don't have a whole, we have plenty of time, but I just don't want to. You guys know how to type it in, right? Stat into edit in list 1, you put in your x values, in list 2, put in your y values. Yes. Stat, calculate, quadratic. We're all good at that?
So the first one's...
No, we know it's quadratic, but it says write an equation. We haven't written the equation. So, yeah, good question.
And that's just the first time it's linear, the second time it's quadratic, and if not, it's exponential.
But on the test, it might say or none, so you'd have to test to see if it's exponential. So with this one, let's see if it's linear, quadratic, or exponential. So I always start with, why not differences? What's negative 2 minus 3? Negative 5, right? Negative 7 minus negative 2 is negative 5. Negative 12, and you can do it on your calculator. Make sure you don't mess up on the negatives and stuff. It's negative 12 minus negative 12 minus negative 7, negative 5, and negative 5. So they were the same when we took differences once, so it's linear. So you'll do the same thing. Stat, edit, and then down to, you'll hit stat again, over to calculate, and then linear regression line, right? So it would have come out to be y equals negative 5x, and then plus 3. And then with this one, if you take differences, okay, so I can just see that it's not, okay, so 6 minus 3 is 3, right? 12 minus 6 is 6, so we know it's not, and then let's do one more, 24 minus 12. So it's not linear, right? 6 minus 3, 3, and then 12 minus 6. So it's not quadratic, right? So now let's do erase really quick. Okay, instead of subtracting, let's divide, because it could be none of the above. What's 6 divided by 3? What's 12 divided by 6? And 24 divided by 12. So they came out the same. When you divided, don't say linear, you were dividing, so it's exponential. So then you'll do the same thing. Stat, calculate, exponential regression line. And we also could do it by hand. So with exponential, it's a times b raised to the x, where a is the initial value, which means when x is equal to 0, so I'll do 3, and then b is your factor, which was 2, right? 2 raised to the x. But if you type this one into your calculator, it would calculate it for you. Exponential regression line. Questions? Okay. Okay. Then the next one on the test, there's only one. It will say solve the systems of equation by your method of choice. So you can either solve it by graphing it, finding the intersection points, or algebraically. But if you do it algebraically, make sure you write them as x, y points. So do you want to do it by the graphing calculator or by hand? Graphing calculator is easier, yeah. So x squared minus 2x. But if you raise your hand on the test and say, I can only find one intersection point, can you help me? I'll say no. It's a test. So make sure you can find both intersection points if you're going to do it using your calculator. So you hit graph. I can see my quadratic. I can see my line. So I'm going to do second trace, find the intersection points. So I have to get close. I can see it's intersecting in two places, and it will. So you've got to get close to one intersection point. Hit enter on the first curve, on the second curve, hit enter again, hit enter again. So we know one intersection point is at 2, 2. I got 1.999, 1, and 1.999, which is 2, 2. Did you get 2, 2? So yours calculate, but then 2.7 wouldn't have been the same as mine. Are you sure?
Yes, it is. Like 2.000.
Oh, 2.0, okay.
Much more.
Wait, what? And what was your second point?
2.00014.
Oh yeah, so 2 and 2, same thing, right? Okay, gotcha. Yeah, it is. That is the same thing. And then second trace, so that's the only reason I like algebra is because you won't, it'll be exact, so that's fine. So intersection, find the other one. You can always, it's always easy for people to find one. It's always hard for them to find the second one. So I just found the second one, and I got, I get 2, oh. Okay, so I already found that one. So see, this is where technology is having some issues.
I got a different one this time.
Okay, so I'm going to try mine again and get closer to a different intersection point. I must be too close to the same one. Why?
Can't you just do like 2x minus 2 equals?
Yeah, that's the thing. Like, you see how my calculator is malfunctioning? See, I can't get the second. My calculator's being picky, so I would just opt to go to the hand thing real quick. So we'd have x squared minus 2x plus 2 is equal to. So yours was able to get the second one?
Well, it was what you got the first one.
Oh, that's weird because they're both 2, 2. So let's do it by hand and see what's happening here. So we have 2x minus 2x plus 2 is equal to 2x minus 2. And because they're both equal to y, they're equal to each other. So we would subtract 2x, right?
Yeah.
So we would have x squared minus 4x plus 2 is equal to negative 2. We would add 2 then. So we would have x squared minus 4x plus 4 is equal to 0. So then, oh, yeah. So this is one that only intersects in one spot, because let's keep going. So let's solve it. So I'm going to solve by factoring. What multiplies to be 4 adds up to be negative 4. 2 times 2, right? Negative and negative, right? So then it quick factors to be x minus 2 times x minus 2. So we get 7 equal to 0. So we'll get x is equal to 2. X equals 2. So here was an example. That's the same thing, right? So we would say, okay, so we know 2, comma, plug it back in. What's 2 times 2 is 4, right? 4 minus 2 is 2. So 2, comma, 2. And then we already got 2 like that second time, so we'd get it again. So this is only intersected in one spot. So this was an example. I'm glad we did this one, because I was thinking they'd always intersect twice, but that was an example of it only intersecting once. Yeah. But usually we get 2 intersection points, right? So like, let's say we got x is equal to 2 and x is equal to 0. You had 2, so you plugged in 2 and got 2. And then let's say like 0 was the other intersection point. You would have got 2 times 0, which is 0, right? Minus 2. So usually there's 2 intersection points, so most of the time. Is everybody okay with that? Okay. Okay, so now use the discriminant to determine the number and type of solutions you have. So first of all, make sure it's set equal to 0, and then we'll find the discriminant, which is just the b squared minus 4 times a times c. If you know the quadratic formula, you know your discriminant, because remember it's under the square root, right? B squared minus 4ac. Okay. So when you calculated that, you got 85. So the discriminant is just 85, not the square root of 85. So because it's positive, our answer would be 2 real solutions. Is everybody okay with that? Don't write the square root, because I'll have to mark it wrong. Okay, with this one, what's my discriminant? So 4 squared minus 4 times 2 times 2, b squared, minus 4 times a times c. What do we get?
0.
0. So what's our answer? 1 real solution. Because the square root of 0 is 0, and plus and minus 0, because the quadratic formula, that's where our 2 solutions come from. And plus and minus 0 is the same thing. So then, if you calculate this one, you'll be doing negative 4, b squared, minus 4 times a times c. Negative 80, yep. So we got negative 80. So in this one, our discriminant's negative. So yeah, we would have an I. But this is our discriminant, and we know we'll have 2 imaginary. Questions on those ones? Okay. Then on the test, the next one will be simplifying complex numbers, which are the easiest ones, but yet missed a lot. So you have to check. Do not multiply if you're not multiplying. Right here, we're not multiplying, right? We're just subtracting. Well, yeah. Yeah, so negative 1 times 5 is negative 5, right? And then negative 1 times positive 2i is negative 2i. Now a lot of people double dip. They'll say minus negative 5. No, you just took care of all that stuff. So just scribble it out if you need to. Is everybody okay with that? So now just combine like terms. 2 plus negative 5. Negative 3. So I just added up those. And then 1i plus negative 2i. Or I, right? Positive or negative? 1 minus 2. So negative 1i.
But then don't go to it. Does the negative I mean something?
I squared is something, but I is nothing. So this is our answer. And it's in the form of a plus bi. So we always like a real number part first. So with this one, make sure you look in between. We're not adding, we're not subtracting, we're actually multiplying. 1 times 1 is 1. You've got to distribute on this one correctly. 1 times positive 5i is plus 5i. Then negative 5i times 1. And then negative 5i times positive 5i. Careful.
Negative 25i squared.
Good. Negative 25i squared. Way to go. So let's also change it. So we have negative 25 technically times negative 1, right? Which is plus 25. So now we've just simplified that, so don't double dip. We've taken care of all that stuff. So we have 1 plus 25, which is, and then positive 5i's minus 5i's. 0's i's, right? So we won't write it. So it's that. But don't make the mistake of saying the i's are always going to cancel out. What if it would have been negative 5i minus 5i? It wouldn't have canceled out, right? It would have been negative 10i. Okay. All right, so next one. Once again, you've got to check. Am I multiplying, adding, or subtracting? Oh, I'm multiplying. Try to catch that. Okay. Negative 2 times 3. Negative 2 times positive 4i. I times 3. Positive 3i, right? 1i times 4i. And it's positive 4i squared. And we know I squared is negative 1, so really we got 4 times negative 1, which is negative 4. And then don't double dip, because we just simplify that. Negative 6 minus 4. Negative 8i plus 3i. Yes. Okay, questions on those? Okay, and then with this one, are we multiplying? No, don't multiply. That would be really bad. We're just combining the terms. It's addition. Negative 7 plus 4. Negative 3i plus negative 8i. Negative 11i. Questions on that? 3, negative 3 plus negative 8 is negative 11. Okay, what about something like this? Let's simplify it in pieces. So we have 10 minus 7. Isn't 7 multiplied to negative 49i? What is, it's right next to each other, right? So what is negative 49i?
Square root of 49?
The square root, sorry, of negative 49. 7i, right? Not negative 7, okay? If we have a negative under square root, it's I. So we have 7 times 7i and then plus 2i, right? Everybody, do you see what I'm doing here? So we have, now don't do 10 minus 7. Isn't 7 multiplied? Think about order of operations. Don't you multiply before you subtract or add? So we've got to actually multiply that together first. So we have 10 minus 49i, right? 7 times 7?
Yeah.
Minus 49i, and it was negative 7 times 7, which is negative 49i plus 2i. Then now we'll just combine like terms. 10, nothing else. And then we're going to have negative 49 plus 2, which will be negative 47i, right?
Is this test
No. Okay, find the radius and the center of the circle. So the center is at what? Negative 2. You go opposite, comma, 3. Good. My radius squared is 16. Therefore, my radius is 4. Questions on that?
Can't you do like parentheses x minus 2 to the square root and plus parentheses y plus 3?
No, we were given the equation in this one. We're just finding the center. Like, if we went backwards, we'd end up back here.
Oh.
Like, we were given this, we were writing the center and the radius. So with this one, what's my center at? Was there any shift left and right? Was there any shift up and down? Okay, and what's my radius? 8. You took the square root of 64. Okay? Make sure that if you are looking at something like this, you always go the opposite, right? So that's why it was positive 3 and negative 2. Okay, one more. Write the equation of the circle. So this time now we're writing the equation of the circle. So our center is at positive 2, positive 5. So this is x, y, right? So we're going to do x minus 2. Don't forget the squared part. And then don't forget the plus sign. Y minus 5. You always go opposite. Squared is equal to 7 squared, which is 40. Good. Okay, so those ones are easy. All right, so if I asked you on the test, when you're solving a quadratic, aren't you, like, what does that mean? Aren't we finding the zeros, which are also called roots? Same thing, which are also called x-intercepts. So if I said, what are we doing when we find the roots of a quadratic? We are solving. What if I said, what are we doing when we find the x-intercepts of a quadratic? We're solving. You get what I'm saying? If I said, find the zeros of a quadratic, what are we really meaning by that? You would say we're solving, right? Or finding the x-intercepts. Do you get what I'm saying? As long as you word it and make sense, then you're good. That's really everything. So you'll do good on the test. So those of you that came in late, if you want me to go back to the first and talk about a few things, I guess I can. Okay.
So you know when you get when you're doing quadratic properties, and then you get the square. Well, you get the derivative, and then you square root it.
The discriminant?
Yeah.
Oh wait, yeah. So you're asking if what?
So when you have to square root the derivative, and it's not, you can't like break it down. Or no, when you break it down.
Like for example, the square root. Let's say you had 2 plus and minus the square root of 80 over 3.
Yeah.
So you'd say, okay, 80 breaks down into 8 times 10, right?
Yeah.
8 breaks down into 4 and 2. 10 breaks down into 5 and 2, right? 4 breaks down into 2 and 2. Then we have 2 2's, right?
Yeah.
2 2's, and then 5 has to stay.
Yeah, what about the 4 though?
The 4 was...
Oh yeah, you broke it down.
Yeah, so don't double dip.
And so how would you write it back?
So
into
2 times 2 is a 4, and left underneath was 5, so it'll be 4 square roots of 5.
But you have 2 times.
Right. You don't pull out a 4 though, right? You pull out 1 2 for those 2 2's. You pull out 1 2 for those 2 2's. So 2 times 2 is 4.
All right.
Yeah. He was just asking me. This had nothing to do with this. Like I just randomly wrote that. Yeah.
And so it'll be 4.
So then you have 2 plus and minus 4 square roots of 5 over 3, and then look, do all 3 things simplifying? No.
Okay.
Okay.
So on the test, you want us to put the plus and the minus separate, or can we?
You can leave them together.
That's important.
Okay, so for those of you that thanks for being here. Yep.
I only got the text message like
Yeah, there wasn't very many people here. This will be the last early one for you I do ever.